Greetings all, this is Satchmo3 of the 405th. I've put together this unfolding tutorial to illustrate some of the practices I use when performing unfolds for 3D models. I'm hoping this tutorial will help interested community members in improving their overall unfold skills. If you have any questions or comments, please feel free to post in the thread below. Before we begin, I should mention I'm assuming you, the viewer, already have some familiarity with the Pepakura Designer program. If not, I recommend you visit or search out the Tamisoft Pepakura Designer website, where you'll be able to download the program as well as find instructional and help files to run it. On screen is an overview of the topics I'll be discussing. We'll start by taking a look at a unfold I've previously completed. We'll be considering the Halo 4 War Master helmet. So we'll look at a completed model to identify some of the goals I strive for when performing an unfold and the practices I use to meet those goals. Then we'll move to creating a new unfold of the same model. We'll start by defining open edges in the 3D view before we unfold the model. Then we'll unfold the model and set up the part organization in the 2D view. From there, we'll finish up by refining the part organization in the 2D view and completing the unfold. To begin, we're in Pepakura Designer 3, looking at an unfold I've previously prepared for the Halo 4 War Master helmet. On the left side of the screen we have the 3D model view, and on the right side of the screen we have the 2D parts layout. Now when preparing an unfold, we primarily want to consider the end user for the file. And the end user is the person preparing or assembling the paper. We want to make it as least time consuming and as easy to put together to minimize any kind of mistakes. To that end, what I try to do is maximize the size of our parts. So what that ends up doing is decreasing the amount of cutting and gluing the assembler has to do, decreases the amount of parts the assembler has to keep track of, and it decreases the amount of edges that the assembler has to align, and that decreases, chances of misalignments that could lead to skew and distortions with the overall paper when it's glued up and put together. So, trying to maximize part size, what I find that I usually end up with is long strips of paper, or parts made up of multiple long strips of paper. If I open up the size of the openings in the 3D model view, we see these long strips of paper or multiple strips of paper within the part that follow the natural contours and curves of the helmet or whatever file you're working with. We specify it to follow these curves because that minimizes the amount of fold lines that are contained within the part. All the harsher angles will be towards the outer edge of the strip, where the assembler will have to be folding anyway due to the connection tabs. Now, when specifying the edges or the ends of my long strips, I'm trying to think of how bricks are laid. When a brick wall is laid, the ends of the bricks are offset from the next row of bricks. In that same manner, the edges of my long strips are offset from the edges of the adjacent piece, and what this will do when the person assembling the paper is assembling the paper, it creates a better structural stability for the paper model. So those are kind of the primary goal, which is to make the paper as easy and quick to put together as possible, and we do that by creating these long parts or parts made up of these long strips.